66, we got a factor, and write the polynomial as a product of linear factors. So let's get on with this for number 66. All right, so we're going to put P over Q here. P over Q is what the book likes to use for possible rational zeros. The P represents the possible factors, or not possible, but the factors of 35, and then Q represents the factors of the 1, the leading coefficient. Actually, wouldn't it be better if it said C over LC? I don't know. The factors of C divided by the factors of LC. Okay, so we have, what is that? For C, it would be 1 plus or minus. We can divide it by a positive 1 or a negative 1, a positive or negative 35, a positive or negative 7, a positive or negative 5. Anything else that'll divide 35? Well, 15. Nope, 15 won't work. Okay, and then for the 1, it's just positive or negative 1, which is beautiful. We love it when it's just a 1 because that means we don't have to make any fractions or anything like that. I'm not going to write it out. So these are your possible rational zeros. 1 divided by 1, 1 divided by negative 1, 35 divided by 1, 35 divided by negative 1, 7 divided by 1, 7 divided by negative 1, and 5 divided by 1, and 5 divided by negative 1. So that's a total of 8. 8 possible rational zeros. Well, how do you know it's possible? Because it's a factor of this guy. Oh, well, how do you just know? Oh, you got to do it, fool. We got 1, 9, 27, and 35. What I'm going to do right now is I'm going to see if one of these factors is a zero by using synthetic division. And I like using synthetic division because after you do this, and it does work, you can continue factoring from where you left off. So let's try 1. If I try 1, I first bring down the 1, and I go 1 times 1, which is 1, and I get 10. 10 times 1, which is 10, we get 37. 37 times 1, which is 37, which does not equal 0, right? Right. So this one doesn't work. Positive 1 doesn't work. What about negative 1? 1, 9, 27, 35. So, bring down this 1. 1 times negative 1 is negative 1. Then we get an 8. 8 times negative 1 is negative 8. And then we get, what is that? Is that,
19.
Wow, I'm drawing a blank here. It's 19? Okay, 19. 19 times negative 1 is negative 19, which does not work. Wah, wah. All right, I definitely don't want to try 35. That's a big number. Let's try 5. Okay, so 1, 9, 27, and then 35. Okay, so we bring down the 1. We get 1 times 5, which is 5. 5 times 9, or 5 plus 9, which is 14. Oh, this is just going to get bigger and bigger, huh? We're going to have to get a negative in there. Negative 5. Let's try that one. 1, 9, 27, and 35. Let's see if it works, shall we? So we bring down the 1. We get 1. 1 times negative 5 is negative 5. Negative 5 plus 9 is 4. 4 times negative 5 is negative 20. And then I get a 7. Oh, snappity baggity shaggity. Oh, we're so stoked because 7 times negative 5 is negative 35, which gives me a 0. You know what that means? I'll tell you what that means. That means x plus 5 is a factor of this foo. And the other factor is 7, positive 7, 4x, and 1x squared. Where'd you get that? From this guy. There's your 7, there's your 4, there's your 1, x squared. Okay, so now, can I factor this? Can you guys think of something that multiplies to give me 7 and then adds to give me 4? Nah. Now, this is what you can do. You can keep trying numbers over here, but that'd be kind of foolish. Because if there's a number over here that works, then this would actually factor out nicely. It would. So how would we, factor this quadratic right here? Oh, the quadratic formula. Let's do that. Negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times 1 because that's what a is. So that's 2. That's just going to be negative 4. This is going to be 16 minus 28. Is that right? 28? Yes. Oh, dang. That's why, because we got imaginary number. That would be 22, 12, right? So it's negative 12. And then we factor that out. Negative 12, or simplify. The square root of negative 12 is the same as negative 1 times the square root of negative, or of 4, and the square root of 3. Right? If I multiply all these together, I get negative 12 in there. This is an I, and this is a 2. So let's write that out. We have negative 4 plus or minus 2 square root of 3I divided by 2. And that simplifies to, we got to go this divided by 2 and this divided by 2. So we get negative 2 plus or minus square root of 3I. So how would we write this in a complete factored form with linear factors? Well, we have our x plus 5. He's ready to go. And then the other one's going to be x minus negative 2 plus rad 3I. Just put parentheses around him. Don't bother simplifying anything, okay? Just leave him. And then we got to do the other one, which is minus. So it's going to be x minus negative 2 minus square root of 3I. There you go, a product of linear factors.